Hello everyone, welcome to Economics. Today we will see the chap see the paper Statistics for Economics. In this first we will see the syllabus, what we have to cover during the course. In this paper there are 4 units. First unit is the sampling distribution, in which we will see first we'll see the parameter and statistics. Second we will see the sampling distribution. Third, we will see the central limit theorem. Next, we will go to Unit 2. In Unit 2, we will be covering estimators and method of estimation. In method of estimation, there are two methods, which first is interval estimation, second is point estimation. Next, we will see the properties of estimator, and then we will see the interval, which are based on the different distributions, which are t distribution, z distribution, and chi-square distribution. Unit 3 is the inference. In this we will see what is the hypothesis, what is the meaning of hypothesis, what are the errors which are incurred during the hypothesis testing, and what is the power of a hypothesis test. And in the Unit 4 we will do the hypothesis testing. So this is the syllabus which we will cover. So we will start with the first topic, which is the statistics and their distribution. In any population, if we select some observations from any population or any data, that is called the sample. And any sample we denote, it can be any denotion. Let's say we are denoting any sample with x1, x2 till xn, in which there are n number of observations. For example, like from a number, we select 10 numbers, 1 to 10. So it is a sample of 10 observations from n natural numbers. So it is a sample of 10. Like this, anything, any small sample or any small observation which we select from a huge population, that is called a sample. So there are two things. First one is the parameter. Parameter is a number which is used to describe a population. Parameter, it is a number which describes a population. And statistics is a quantity which is calculated with the help of sample which is derived from a population. So with the help of sample statistics, we can describe what the population parameter is. So statistics, it is the number or value derived from a sample which is randomly selected. Statistics which is calculated from a sample which is randomly selected. So statistics is a random statistics because it is calculated from a random sample. Since statistics is calculated from a random sample, so anything which is randomly selected and calculated from a random sample will have a probability. So probability, if it has a probability, it will have a probability distribution which we can calculate the possibility of other variables which will lie in that value. For like statistics, anything which is like observed, it is expressed by uppercase, and whatever value which is calculated, it is expressed by lowercase. For like example, when we are thinking of selecting a sample and saying we will calculate sample mean, sample variance, then what? Then we will denote that sample mean by x bar, because still now this is not calculated and still it, the sample is not selected, so we will denote it by uppercase x uppercase, which is the mean. But after we have selected the sample and calculated the mean and everything, then we will denote that mean by lowercase x bar, because this is the expected value and this is the observed value which we have already calculated, so now it will be expressed at lowercase. Next is the probability distribution. We will talk about what is probability distribution. Since we know that statistics is a random statistics because it is calculated from a random sample, so it will have a probability distribution. Probability distribution is also called sampling distribution because it shows that how the statistics is varying across all the sample. For example, x bar is 0 if let's suppose we have two value x1 x2. When x1 and x2 is 0, we can say that x bar is 0. When x1 is 0 and x2 is 1, we can say x bar is 0.5. And when x1 and x2 both are 1, we can say x1 is 1. So with this, there is a probability involved in this, and with this probability distribution, we can calculate other sample across it, that what is the probability of x being 3, like what is the probability that x lies between 2 and 1. So probability distribution tells us the tell us the probability that our statistics, how our statistics is ranging between the whole sample. Probability distribution of any sampling depends upon two things. What is first is what is the distribution of population, और दूसरा कि हमारा sample size या population size क्या है. So कोई भी sample n number of sample हम select कर रहे हैं, वो random कैसे होता है? Why it is called random sampling? The random variable x1 x2 till xn is said to form a random sample of a size n random sample of size n if first xi is randomly selected, second the probability of selecting each xi is equal. In short, we can say that it is independent and identically distributed, which is IID. A random variable is independent and identically distributed. And this condition is only satisfied when the sampling is done without replacement. If a random sampling satisfies these two things, it is randomly selected and the probability of selecting xi is same, then in short it is called, it is independent and identically distributed, and this condition is satisfied only when sampling is done without replacement. For finding the probability distribution of any sample, there are two methods. First is probability method. Second is simulation method. In probability method, the probability techniques are used to find the distribution. This method is used when the sample is very simple, it is nicely organized, and there are less number of variables for which the calculation of probability is easy. But when there is the sample are But when the sample is little bit complicated, it has a complex values and it has complex number, then a simulation method is used, which is usually carried out with the use of computer, with the use of software, which gives us the distribution. स्टार्ट करेंगे नेक्स्ट मेथड से, जो कि है सिमुलेशन एक्सपेरिमेंट. सिमुलेशन एक्सपेरिमेंट में हम किसी सॉफ्टवेयर या कंप्यूटर का यूज़ करके किसी सैंपल का प्रोबेबिलिटी डिस्ट्रीब्यूशन निकालते हैं. उसमें सॉफ्टवेयर या कंप्यूटर का यूज़ करने का ये बेनिफिट है कि हमारे पास जो कॉम्प्लेक्स सैंपल होते हैं जिसे हम नहीं डील कर सकते विथ आर हैंड डायरेक्टली, क्योंकि वो बहुत कॉम्प्लेक्स है, बहुत लार्ज डेटा सेट है, उनके डिस्ट्रीब्यूशन बहुत लार्ज है, तो हम सिमुलेशन एक्सपेरिमेंट्स करते हैं. इसमें हमारा चार चीज हमें पता होना चाहिए. पहला, हमारा क्या स्टैटिस्टिक्स हम निकालना चाह रहे हैं. सेकंड, हमारा एन नंबर ऑफ ऑब्जर्वेशंस कितना है. तीसरा, हमारा पता होना चाहिए क्या टाइप ऑफ डिस्ट्रीब्यूशन है हमारे सैंपल का. क्या टाइप है हमारे डिस्ट्रीब्यूशन का. और हम फोर्थ, हमारा नंबर ऑफ सैंपल्स. ये एन और ये नंबर ऑफ सैंपल इसलिए डिफरेंट है. ये एन हमारा किसी एक सैंपल में कितने ऑब्जर्वेशन है वो शो करता है, और ये नंबर ऑफ सैंपल ये शो करेगा कि हम किसी पॉपुलेशन से कितना सैंपल लेंगे. जैसे एन नंबर ऑफ सैंपल का 4 सैंपल्स चाहिए हमें, तो ये हमें पता होना चाहिए किसी भी सिमुलेशन एक्सपेरिमेंट को फीड करने का. इससे हमें डायरेक्टली हम ये सारे इंफॉर्मेशन डालेंगे तो हमें कोई भी सैंपल का डिस्ट्रीब्यूशन क्लियरली इन द फॉर्म ऑफ ग्राफ या फिर टेबल वो शो कर देंगे. ये तो अभी यहाँ शो करना पॉसिबल नहीं है. ये इन फ्यूचर अगर हम कभी ये दिखाएंगे तो कैसे किसी सिस्टम में ये सिमुलेशन होता है वो शो कर सकते हैं. ठीक है. सो हम नेक्स्ट टॉपिक में जाएंगे. हमारा डिस्ट्रीब्यूशन ऑफ सैंपल मीन. ये हमारा सैंपल मीन का क्या डिस्ट्रीब्यूशन है. जिसे हम स्मॉल एक्स बार से डिनोट कर रहे हैं कि हमारा सैंपल मीन जो है वो कौन सा डिस्ट्रीब्यूशन फॉलो करता है. हमारा कोई भी रैंडम सैंपल है, किसी भी पॉपुलेशन से रैंडमली सेलेक्टेड सैंपल है, और हमारा मीन है एक्स बार. So now there are few formula which will be used in the future for the calculation purpose. First, sample mean. Sample mean is important to find that population mean, what it tells about the population. So first formula is E x bar, which is the expectation of x bar, which tends to be equal to the population mean as the sample size increases. Second is the variance of x bar, which is the sigma x bar square. So formula is sigma square by n. When we take the square the other side, so sigma x is equal to sigma by root n, which is usually the standard error of any sample. And this standard error is used in the further calculation of the distribution and z score. One more thing is, we have a sample x1, x2 till xn. So the sum of this sample is denoted by T0, which is x1 plus x2 till xn. This is the sum total of the sample. So what will be the expectation of T0? So expectation of total will be n mu. That is what is the mean, and a number of sample will give the expectation of sum of the total sample. And the x variance of T0 n sigma square. That is the variance of sample mean into number of observation n. And T0 will be root n sigma. Central limit theorem. So central limit theorem tells us about the distribution of x bar, which is the distribution of mean of any sample. It says that whatever the distribution of population is, first let's see if the distribution of population is normal, then its mean will also have a normal distribution. Let's say n is equal to 20 and it is normally distributed, then the mean of this sample will also be normally distributed. But what if our population sample is not normal, it is skewed? So in case of our population is skewed and n is relatively large, then the mean distribution of mean may tend to be normal. This is because of the central limit theorem, which says that as the n increases, whatever may be the distribution of population, it doesn't matter, the distribution of mean will be normal. So let's see our the theorem is like this. Let's say our sample x1, x2 to xn with mean mu and variance where n is sufficiently large then the distribution of sample mean will be normal. This is the central limit theorem, which states that whatever the distribution of population, it doesn't matter if n is large. So what is the bar of n? How much n should be so that we can say that sample mean distribution is normal? Generally, whenever n is greater than 30, we consider the sample to be large. And if the n is 30, even if the population distribution is skewed, the mean distribution will be normal. And for this theorem to be correct or give correct approximation, it is necessary that n is sufficiently large. If n is 20, let's say for example, and the distribution is skewed, then we cannot say if that the mean distribution is normal or it is skewed, because n is very small to predict anything or to see anything. And if the n is more than 30 or 40, then every time the distribution will be normal mean distribution, and the shape will be the distribution shape will be like a bell shape, which is evenly distributed